Good afternoon, students. Welcome to the session. How are you all? Welcome to one more amazing session from Infinity Land by Sri Chaitanya. How are you all doing, my dear students? Good afternoon. Please confirm, can you able to hear me? You can see me, right? Anamani alone, right? Many students are there eagerly waiting for today's topic of interest is connect with NCERT, especially for inorganic chemistry. Today and tomorrow, I focus mostly on inorganic chemistry, and every people says when you take an advice and when you want to study for NEET examination preparation, everybody gives you a advice like connect with NCERT, study NCERT. And when a student open the NCERT book and you see many lines are there, many side headings are there, you study and close and try to open an objective, and in the objective you will be having a different version of questions and different explanations and how it is related to NCERT as हमारा class में चर्चा करने वाला है. And very good, thank you very much. And one more important thing, and this YouTube platform by Infinity Learn, we are offering physics, chemistry and biology sessions right from 12 o'clock to evening 6 o'clock, Monday to Saturday, and everybody and regularly attend these sessions, and my sessions are going to be 1:30 to 3 o'clock every day. And you just like and share and subscribe to this NEET channel, right? And looking great today, thank you very much. And you know my coupon code also. That's good to see. And my dear students, what this Infinity Learn is doing for the student community, for who's dropping 12th standard and preparing for NEET 2025 examination. Yes, we are offering chemistry, physics and biology NEET STEP UP program. And I just want to show a few students of performer here and double score proven results with our NEET droppers program. You can see Ashrita, who secured just 310 and got 661 marks in NEET 2024, and there is an improvement of 351 marks. And you can also see Akhil Verma, who secured just 313 in 2023 exam, my dear students, and he took a program from Infinity Land. He secured 658. Just to see amazing improvement in the program. Also you can see Hema Duty 342 tha, abhi 652 ban gaya, and she is proudly going into the medical college now, and 342 marks improvement is seen. And Satyanarayan, and who secured just 330 and got 650, you can see 320. You can see these statistics, the score is amazingly doubled, and the credit goes to Infinity Learn scientifically designed academic program. So what you can do, not only these 4 students, many students, hundreds of students done like that, and you will be the next for this slide. Are you ready? Right. And also you can see what NEET program is given for us, and Infinity Learn is offering you NEET 2025 rank assurance program, and these are the silent features, you never get it anywhere in the world, but Infinity Learn is doing for you. And there are 480 plus hours of live class with complete NEET syllabus and downloadable notes, classroom recordings and DPPs also awaiting for you. And there are 5,000 topic wise recorded videos, kamal hai. And chapter wise previous year question along with video solutions are available, and also weekend test series with rank analysis and paper discussion bhi hoga, and full syllabus mock test with detailed reports, and 24/7 kahi bhi kabhi bhi doubt aapka ek button, a doubt is a button away, and you can just press the button and the doubt is going to be explained to you. And there are 30 Achiever series printed notebooks. Simply it is for you, and it reaches to your doorstep. Dear children, how many features you can see, and there are parent teacher meeting, and also very important thing you can see, there are 9 students all over India who secured 720 out of 720 from Infinity Land. from this program, and 45 students got below 100 All India Open category ranking, and also 132 students scored 700 plus. How amazing these are! And these are all NEET in NEET prominent faculties, and not only these, many of the pool of faculties are going to give this program. And what you can do, simply you can enroll in any course simply by taking, this is your web page and this is the lecture that is going with me, and just scroll up and you're going to see a description here, and click on more and you're going to see various links that are given. Just check the first link, boost your NEET score with Infinity Learn, enroll now, and you just click it away and you're going to direct you into one more page, and in this page you can see all the key features of the program that are being given. So comprehensive video lectures, personalized learning experience, detailed study material, and also targeted practice questions. These targeted practice questions, if you do, you can check these questions from your आने वाले एग्जाम से, है ना. और एक चीज है, नेशनल लेवल मॉक टेस्ट एंड परफॉर्मेंस बेंचमार्किंग, and also unlimited practice test and expert doubt resolution, efficient revision tools. Not only this, many key features are there, and to improve your score to the higher level for the droppers, the program is going to be started August 16th, and you can check, these are the slashed prices are already available. Let us say this is the course 15,000, it was 15,000, it is slashed. 5 just given for 9,000. You just click it away and you are going to take you to verify your phone number, and also it will be given to you 9,000 से इससे सस्ता आने है, कैसे आना है देखो, and you will be given a coupon code. What is the coupon code, Anamai? Yes, you are having restart your preparation for NEET 2021. You can use the coupon code Suresh50 in the payment gateway. You just apply the code Suresh50, so that 9,000 से 20% discount flat you are going to get, so that इससे सस्ता कौन देगा आपको. And it is going to be an awesome experience with your NEET Infinity Learn platform, and your journey of NEET preparation is going to be smooth, and you are going to end up with an excellent result and a topper ranking, right? And don't forget your Suresh50 coupon code, right? You're all with me. So the formalities are completed. Let us talk about the NEET Inorganic Chemistry. In the NEET Inorganic Chemistry, it is little jumbling. It is jumbling. How it is jumbling? A chapter is connected to one more chapter. Some question from the P block element. This P block element, if you see this P block element, 11th standard group 13 and 14, and 12th standard 15, 16, 17, 18 groups are there. In this P block element, a question can be asked. That question can be connected to the classification of elements and periodic properties and chemical bonding also. And also you can see the D and F block, hydrogen, S block, metallurgy and complex compounds. Sir, S block is out of the syllabus. Don't say that, because so many connected to chemical bonding. If somebody is asking about lithium chloride, sodium chloride lattice energy order, so it is, you claim that it is an S block element, but I can claim as a paper setter it is from chemical bonding. Yes, so that you don't feel that this chapter is eliminated from NCERT, this chapter is eliminated from NEET syllabus. So whenever it is asked, you have to answer it. Say an example, metallurgy is there, it is simply feel that it is eliminated, but it is asked in 2024 also, right? And also you can see complex compounds, every year 3 questions. 2024 you can say 3 questions. Metallurgy, 1 question is asked. And you can see, and D and F block, 2 questions are asked. You can see P block elements, how important it is, 6 questions from 19, and 2028 and 1433 it is coming like that. So that I request, my advice, my dear students, you study all the chapters without any deviation, but among all I focus mostly on chemical bonding and molecular structure and classification of elements and the periodicity. So focus there, and other students come on, ping something in the chat box so that I can see the students are active. So I am going to present my lecture in today's way. A few questions will be discussed, and many of the students were asking about sir, ionic compound everybody knows, and properties of ionic compound, इसमें इतना डेप्थ कैसे NCERT का कनेक्ट करने तो. So like melting point, boiling point and solubilities कैसे पकड़ना, इसका ऑर्डर क्या होगा, इसका टिप्स एंड ट्रिक्स एंड लॉजिक्स भी आपका सामने अभी है. हाँ, बहुधारिणी, गुड आफ्टरनून, हाउ आर यू ऑल? Okay, so many students are there. Okay, so the other student's name I forgot. Bhavadharini, Annamani is there online. Who are the regular students? Just give a ping in the chat box. So how was your previous week classes, Bhavadharini? You all did your, yes, all did your organic chemistry multiple choice questions connected to the NEET, right? And today get ready for inorganic chemistry, today and tomorrow. So random inorganic chemistry picks. Ready? Bhavadharini, ready? Okay, so let's talk about something is given from the NCERT. It's a snip from the NCERT. So look at this snip. So I don't want to propose the page number and all, because before COVID, during COVID, after COVID, in the 2024 also, NCERT textbook page numbers has been revised. Okay, the process involves both attractive forces between ions of opposite charges and repulsive forces between ions of like charges. The solid crystal being three-dimensional, it is not possible to calculate lattice enthalpy directly and interaction force of attraction and repulsion only. Factors associated with the crystal geometry have to be included. So, it is given something narration as you are sailing somewhere. You are in the middle of the sea. It is related to lattice energy. It is related to lattice enthalpy. What is lattice enthalpy? Based on this, how the question can come. You can see, choose the correct order of lattice enthalpy in the following. So, based on this particular phrase from the NCERT, a question has been given, right? So, what is a lattice energy? Let me explain you the concept and I'll give you the correct explanation for that, right? So, I mean to say, lattice energy, so when a metal in the gaseous state and a non-metal ion in the gaseous state, it is going to give rise mx, which is in the solid state, and heat is released. This is what you call it as a lattice energy, right? Simple. So lattice energy is the amount of energy that liberated when 1 mole of ionic solid is formed from its constituent gaseous ions. That is what you call it as a lattice energy. So what are the factors that influence the lattice energy? That's very simple. Lattice energy is directly proportional to the charge. First simple thing, it is going to be charge. So what I mean to say, and NCERT इतना कम देते, इससे इतना लंबा एक्सप्लेनेशन पकड़ के ये छोटा सा क्वेश्चन आंसर देना है. So you open any book, Arihant or Dinesh or Pradeep or Singes, whatsoever the book, ABC, Exampedia, whatever, and the questions are being given, appropriate explanation also given, and behind the appropriate explanation, kaun sa pakadna hai. And also lattice energy is directly proportional to charge density and also say size of cation, and lattice energy is directly proportional to size of anion. And you can see lithium fluoride and lithium chloride, lithium fluoride and lithium chloride. So you can say lithium and fluoride, and lithium and chloride, like that. Among these two, lithium chloride is going to have more lattice energy than chloride, and similarly for lithium, sodium fluoride is more than chloride. So as charge size of cation increases, lattice energy is going to be decreased, right? So these are the basic version of the questions that you can see. I just want to go option B is the correct answer. Writing? Fine. Very good. So like that we are going to see some topics like that, and after these topics we are going to see a particular concept from boiling point, melting point, solubilities and hydration energies, and what are the conditions, everything. And if you open a book and write all these points together, so that you are going to get awesome experience, right? Okay, very good. Or a question, get ready with that. Or a question, and here it is a given. An yellow solution of sodium chloride is filtered and acidified with sulfuric acid to give a solution from which orange sodium dichromate Na2Cr2O7.2H2O can be crystallized. So this is a just a snip from the NCERT textbook. My dear students, are you there? Annamani? Fine. So students, yes, Bavadarani. And from here, I just want to give you a question. Ready for this question? Ready for this question? Okay. So let's see here. So in the following reaction, which of the following compounds crystallizes out? Na2Cr2O4 plus H2SO4 gives rise Na2SO4 plus Na2Cr2O7 plus H2O. So in this scenario, which is first crystallizes out? And sodium chromate can be crystallized, it is given. Sodium chromate can be crystallized, that is given. So that from the NCERT, I can say sodium chromate can be crystallized. Fine. From NCERT, you can directly give the question like that. And don't feel that NCERT textbook we have to study and ratta marna bar bar. Aise nahi chahiye beta. I always learn the concept behind each and every line from the NCERT. This is a crystal clear example that I am giving to you guys. Fine? Fine? That's good. Go to this question. One more question is ready for you. Now, one more question. Get ready. Bhavadharani. Okay. So, just all the covalent bonds have some partial ionic character. Yes. Covalent compounds have ionic character. Ionic compounds has covalent character. In sometimes, if the electronegativity difference is not so that small. And you can see, and ionic bonds have the partial covalent character. The partial covalent character of ionic bond was discussed by Fazan in terms of the following rule. What are these are called? Fazan's rule, right? So if you know Fazan's rule and 40% of the inorganic chemistry logics in your hand, mind it, right? So smaller the size of the cation and the larger the size of anion, greater is the covalent character of ionic compound. So this is a snip from the NCERT. Okay, it is from chemical bonding. And the greater the charge on the cation, greater the covalent character of the ionic compound, right? So this snip, how this particular NCERT is connected to a question. So a small ripple of the topic we will discuss, and how it is connected to a multiple choice question and a series of multiple choice questions also we can do it. Yes. So get ready. How can we do this? So there is no fire in the chat box in today's class. There is no fire in the chat box in today's class, my dear children. This is a live interactive session on YouTube platform by Infinity Learn. So here every doubt and every interaction is going to be discussed. So don't feel this is like a radio-like session, and it is a live session. I encourage my students to talk to me so that I can also get engaged with you, right? Come on. So Anamani, are you there? Kept quiet, okay? So based on this Poisson's rule, I am going to re-explain the Poisson's rule in today's class with a different slide, and directly from the Poisson's rule how the question can be given. I just want to explain you guys. Identify the correct order. Okay, solubility in water, melting point, and percentage of ionic character, and lattice energy. You can see. Poisson's rule says covalent character is directly proportional to polarization. What is this polarization? A positive and a negative. So this is an ionic compound. So positive charge is going to attract the ionic anion, negative charge anion. So the negative charge of the anion is coming close to the attracted by this positive charge. So that what happened? There was a spherical anion, and the spherical anion become distorted. So this distortion of anion by cation is called polarization. So more the polarization, more the covalent character. So covalent character is directly proportional to polarization. So in that polarization, you can see polarization, polarizing power is directly proportional to charge. The charge can be negative charge or the positive charge. You can also see polarizability is inverse directly proportional to size of anion. And polarizing power is directly proportional to 1 by size of cation. So in this scenario, you all find it: cesium chloride, potassium chloride, rubidium chloride, and sodium chloride and cesium chloride. In that, chlorine is common, but you take cesium, lithium, sodium, potassium, and rubidium, and cesium plus. So this is the ionic size. So if you talk about the size, it is going to be like this. Now polarizing power people says that inorganic chemistry you have to by heart it, but it is logical. Every logic behind the inorganic chemistry should be like this. Yes, killer. Array killer, Wanga, hi you are saying, but you are not saying hi to your sir also. Okay. So lithium plus, sodium plus, potassium plus, rubidium plus, and cesium plus, it is going to be like this. Lithium plus has more polarizing power, so that more covalent character. So the covalent character for this lithium plus, sodium plus, and potassium plus, and rubidium plus, and cesium plus. So as covalent character in this way, and you can say more covalent, less melting point, less soluble. Now we can say solubility in water: lithium chloride, sodium chloride, potassium chloride, rubidium chloride, cesium chloride. So it is given it is more soluble, but it is supposed to be less soluble. So this order is wrong. We have to identify the correct order. Organic chemistry is different approach, inorganic chemistry is different approach. My dear children, I hope you are following here. Just give a thumbs up. Next, cesium chloride less than rubidium, potassium, sodium, lithium chloride melting point. Melting point is going to be highest here, it is given. It should be low melting point. Ionic compounds has high melting point and covalent compound should have the less melting point. So that it is also given wrong. And percentage of ionic character is more covalent, so less percentage of ionic character. Yes, it is correct one. It is correct one. So Amit, good afternoon. You came late here and after you Abhinav should come. So hope you are following. When did you come? You just came now. Okay. Now lattice energy. So lattice energy more here it is going to be more lattice energy because small size, more charge density, more lattice energy. So more charge density, more lattice energy, so that it is wrong. So my answer for this particular question is going to be C. You just see, just after all is a theoretical question. This is a theoretical question in this inorganic chemistry. You open your book and from any reference material you just see, you spend less than 30 seconds and go away. But I am spending with this particular question along with the concept related to NCERT and spending more than 4 minutes or 5 minutes with you guys and explaining everything behind that. Happy? Clear? Nice to see that. Okay. One more question. Get ready. Amit? Bhavadharani? Oh, no. How do you say? Ionic compounds, stable ionic compounds. Lattice energy is different. Okay. So, more the binding forces, more is going to be the lattice energy. I am going to take a lattice energy special class today itself, don't worry. Right, Amit? Clear? That is a misconcept that you have. Don't follow this misconcept, right? Now let's talk about some more things over here. Yes, that's good, my dear students. One more, salts of oxoacids of S block elements. Again you say, sir, S block elements is not there in the NCERT or you can say in the NEET syllabus. Who said it is not there? If you have a question, total paper is leaked and entire nation is fired, they are firing and nothing we can do from the honorable court, from Supreme Court, right? So I am saying not they are bad or not, neither they nor we. I want to say here some concept is there in this particular chapter. This particular concept can be connected to some other in syllabus topic like a chemical bonding. Yes, so you can see this particular S block elements. Oxo acids are those which the acidic proton is on hydroxy group or an oxo group attached to the same atom, like carbonic acids, phosphoric acid, okay, sulfuric acid. Okay, the alkali metal salts, they are going to form carbonate, bicarbonate and oxalates, phosphates, nitrates, kind of things. And they are soluble, generally soluble in water and thermally stable, right? So simple lines are given as a small stanza. Based on that, yes, I am going to explain that. Amit, hold on, I am going to explain. And how this particular stanza is connected to a question. You can see potassium hydroxide. Potassium hydroxide is preferably used to absorb CO2. Potassium hydroxide is not an oxo salt. Then why it is connected to oxo salts? Yes, it is connected. So potassium hydroxide is preferably used to absorb carbon dioxide. You know, spaceships, submarines, their potassium oxide, potassium hydroxide and potassium peroxide, potassium superoxide salts are used because they are going to absorb carbon dioxide, है ना? And what is the reason only potassium hydroxide is used? And potassium hydroxide is more soluble than sodium hydroxide in water? Of course. So potassium hydroxide is strongest base than sodium hydroxide? Yes, of course. But the reason, appropriate reason, all looks like same. Potassium hydroxide is safer than sodium hydroxide. I never purchased it. We don't know that. And potassium bicarbonate is soluble in water and sodium bicarbonate is insoluble in water. So this is an appropriate answer for the bicarbonates. When potassium hydroxide is absorbed carbon dioxide, or you can use sodium hydroxide also. Yes, they are going to form potassium bicarbonate or sodium bicarbonate, but potassium bicarbonate is soluble so that it can be extracted, whereas sodium bicarbonate is insoluble. Okay, even at low it should be at low temperature, right? Okay, so this is an appropriate answer. So how we are connected to oxo acids? These bicarbonates are highly stable to heat, and most cases the hydrogen carbonates, and they are soluble. They are given as they are soluble, generally soluble. So how we are connected? This is an important slide. So Amit, I'll get back to your doubt, right? Lithium chloride and everything I am going to tell you. And one more, hydroxides which are obtained by the reaction of oxides with water are all white crystalline solids. The alkali metal hydroxides are stronger of all bases and dissolves freely in water and evolution of much heat on account of intense hydration. Yes, Yash. Hello. Okay. So based on this particular NCERT snap, and what is the exact question you can expect it. So this is your question. Which of the following properties shows the reverse trend in radius of moving from magnesium to barium in the group? Okay, so these hydroxides are bases. Okay, these hydroxides are bases. These bases are going to react with salts, acids, and it is going to form salt. And these salts, you can say alkali metal salts and alkali earth metal salts, you can see solubility. But you can see the density is same, magnesium to barium increases, is not reverse. Solubility of sulfates, oxo acids, again we need to correct. Yes, it is following the regular order. So this is not the correct one. So which of the following? It follows the reverse trend. Solubility of oxalates, it follows the reverse order. So I just want to say solubility of magnesium, calcium, barium, and it is going to follow the solubility of oxalate, follows the reverse, and that solubility order I will discuss. Yes, अरे Amit, I will tell you, solubility एक slide है, and it follows basicity of hydroxides increases. Okay, but it is going to be in this way. So in this way it follows the reverse. All are going to be in this way. All are going to be in this way. All are going to be in this way, but it is going to be decreased. So solubility का condition होता है क्या? So various conditions I am going to present here, right? So this is the answer for this question, and keep the answer in your mind. I am going to discuss that solubility after a few questions, right? Or you directly want me to go melting points and boiling points, and after that solubility, whatever. Questions first or concept next, or concept first or questions next? Amit. Definitely, you talk less. Okay, one more question I will complete, then I will go to concept, right? Next, here a question you can see, M2O H2O gives rise MOH, and normal oxide Alkali metals, yes, alkali metal forms normal oxides, peroxides and superoxides. You can see this is a normal oxide on hydrolysis. Normal oxide like sodium plus oxygen gives rise sodium oxide. Okay, sodium oxide, excess of oxygen gives rise sodium peroxide or excess oxide sodium superoxide. So this sodium oxide and sodium peroxide and sodium superoxide, how when they are reacted with water, it is going to give you sodium oxide, sodium peroxide, sodium superoxide. When they are going to react with water, definitely I am going to give you a simple trick to do this. All are going to give their corresponding hydroxides. Sodium hydroxide is formed, sodium hydroxide is formed, sodium hydroxide is formed. है ना? Right. Then sodium peroxide reacted with water, it is going to give rise some hydrogen peroxide. It is going to give you hydrogen peroxide. Superoxide also gives hydrogen peroxide along with oxygen. Now you can see A when react with water gives rise sodium hydroxide. A is going to be then sodium metal, right? This sodium metal that is reacted with 400 degree in the air, it is going to give rise high temperature sodium peroxide. Okay, and sodium superoxide, high temperature no? Sodium superoxide, and it is dissolved in the water, and along with sodium it is going to get oxygen. So it is going to get Na2O, and Na2O2 is the answer for this. Okay, so B is used oxygenating of submarines, okay, and AB are respectively. So it is going to be Na2O and Na2O2. Clear? So like that, a simple thing is going to be asked. And sodium superoxide can be used, potassium superoxide can also be used. And reactivity towards dihydrogen, reactivity towards dihydrogen. So what happened? These metals are going to react with hydrogen. It is going to be metals, alkali metals, S block or say an S block. Yes, of course. Yes, of course. Amit. Okay. So this S block metal hydride. So this metal hydride is soluble in water. It is going to give rise MOH and hydrogen. So what happened? This MH2 can be ionized to give rise M plus and H minus. Okay. So this hydride ion is going to be deposited at anode. I mean to say it is going to give hydrogen gas by the loss of. So it is at anode. Usually hydrogen is going to be liberated at cathode during electrolysis of anywhere, but in metal hydrides it is going to be liberated at anode. You can see electrolysis of KH produces hydrogen at cathode, at anode, either at cathode or anode cannot be predicted. So here it is clearly mentioned in the NCERT, it is going to be H minus. So that H minus at anode, it is going to be liberated at anode is the correct answer. Yes, it is. So just follow it. Everything you are going to get it, right? Clear? Any doubt here, children? Amit? That's good. Next, we are getting into the concept. Wait a minute, huh? No doubts. So, again oxide acids, the same thing, and a question. Which of the following statement is correct? NaHCO3 and KHCO3 have similar crystal structure. La2CO3 decomposes to gives rise Li2O and CO2. And Li2CO3 is soluble in water. All are correct. What is our answer, Amit? What is your answer? You read this stanza and can give your answer. That is really visible to you, and you can give the answer. So like this questions, you can get it for direct NEET examination. How NEET examination can ask a question from inorganic chemistry related to NCERT textbook. So this is your crystal clear example that I want to give you, right? Come on. So Amit, what is your answer? You said it is H plus at cathode. H plus is not there, but K plus you can say. You say all is a trap. Of course, sodium carbonate and sodium bicarbonate and potassium bicarbonate has different crystal structures. Okay, polymorphism they have. So the statement is wrong. So lithium carbonate is soluble in water. Yes, it is said to be. It is soluble in water. Lithium carbonate, the stability, you can see the stability of the carbonates and hydrocarbonates increases. I mean to say solubility. Lithium carbonate, you can see lithium carbonate is not so stable to heat. It is going to be decomposed. Lithium carbonate decomposes, not so stable to give this one. Yes, it is going to be lithium carbonate on heating gives rise lithium oxide plus carbon dioxide. But the other alkali metals like sodium carbonate, you say, you want to heat it gently, so there is no reaction. So any carbonate on heating decomposes to give carbon dioxide except alkali metal carbonates. But lithium carbonate is exceptional one, and lithium carbonate decomposes to gives rise La2O and CO2 is correct. And of course lithium carbonate is soluble in water, lithium carbonate insoluble in water. So I want to say solubility, all are soluble. And it is said that Li2CO3, Na2CO3, K2CO3, Rb2CO3 and cesium CO3, and solubility is less. Okay, it is less soluble. You can say it is almost insoluble. He said it is soluble. It is incorrect. It is incorrect. Fine. And it is directly connected to the NCERT. And this is your NCERT textbook. And this is your NEET. And multiple concepts are interrelated over here. So anywhere, whenever you want to answer a question from inorganic chemistry, it is connected to, of course, it is connected to chemical bonding, either in this way physical properties, or in this way melting point and boiling point, solubility, hydration energy, lattice energy, and everything. It is not like simply retamara. Okay, so I am going to unveil what are the actual concepts related to that. Okay, if sodium plus ion is larger than magnesium 2 plus and S2 minus ion larger than Cl minus ion, which of the following is the least soluble? I'll tell you. This is the constant correlation I just want to give you. More covalent and it is more ionic. It is going to be more ionic. So more covalent means less soluble. And also you can say more charge. More covalent. So that I just want to take it out. I just want to take it this. Magnesium sulfide. Yes, Amit, your answer is correct. Clear? If the charge is the parameter, more charge you have to take a rule number 1, and if charge is the same, you have to take the size into the account. So such a cracky things you can see. Clear? Great to see that, good. Okay, now let's go into more details. Again, Fazan rule. Among lithium chloride, rubidium chloride, beryllium chloride, magnesium chloride, the compound with the greatest and the least ionic. I told na, rule number 1, take charge. Rule number 2, size. This is application of Fazan. Uttam Kumar, good afternoon. Good afternoon. And how today's class of interest is going to be connected to the NEET. This is your NCERT and this is your NEET. How NCERT topic is related to NEET multiple choice question. Got it? You want to say that's absolutely correct answer, Amit. Yes, Amit. That's good. Nice to see that you're given a correct answer. Fine. And of course, this can be S block, this can be P block, this can be D and F block or coordination compounds. Many questions we can just mix 1 or 2. Which of the following statement is true? One statement from S block, another statement from D and F block. You can give it right. Like this. One more. Polarizing power and polarizability and Fazan's rule. So, we will discuss from now onwards. Amit and Uttam Kumar and Anamani and other students. Bhavadharni, are you there? Bhavadharni? And we will discuss about in detailed picture about Fazan's rule. Now, the Fazan's rule decides melting point and boiling point and the solubility. Get ready? So, Fazan's rule. Fazan's rule explains the relative ionic covalent character of ionic compounds, right? So, there are certain things I just want to give in a simple way. Covalent nature is directly proportional to polarization. So, these are the various factors that influence the polarization. A small positive ion favors the covalency. Okay, a small positive ion. So, size does matter. Okay, in a small ions, positive charge is concentrated over a small area. So that इसका charge density ज़्यादा होता है. जिस आयन का charge density ज़्यादा हो, वो आयन का polarizing power ज़्यादा होगा and covalent character भी ज़्यादा होगा. Amit, fine. And a large negative ion favors the covalent. Okay, I just want to say this and these 2 points together. I just want to say small size and a big anion is going to be more covalent. This picture everybody keep in your mind so that whenever you go for examination, that image should come into the. इसका opposite क्या होगा? Opposite. Large anion in the small cation, large cation and small anion is going to be more ionic. more ionic. ठीक है? Large charges on either cation or anion favors the covalent nature. This because the high charge increases the amount of polarization, right? So let's talk about the example over here. Let's talk about example over here. So lithium chloride is more than sodium chloride covalent. Right? Now, large negative, you can say lithium chloride, lithium bromide, lithium iodide. So, the covalent nature is going to be in this way. Covalent nature is going to be in this way, right? So, follow the logic. And you want to say large charges. Large charges means sodium chloride and magnesium chloride. This is going to be the order. और अल्यूमिनियम क्लोराइड, उसमें क्या क्या चार्ज आपको दिख रहे हैं? सोडियम +1, मैग्नीशियम +2, अल्यूमिनियम +3. जिस कैटायन और एनायन में चार्ज ज्यादा हो वो सॉल्ट का कोवेलेंट नेचर ज्यादा होगा. कोवेलेंट नेचर ज्यादा होगा. And not simple as this. I am going to append so many points over here. Okay, and you can see polarization, hence the covalency is favored if the positive ion does not have a noble gas configuration. So I just want to say calcium chloride and zinc chloride covalent. How do you say this is covalent? Array, this is also +2, this is also +2. But the thing is here, you can see this is noble gas configuration and this is a pseudo noble gas configuration. Whenever you have a pseudo noble gas configuration, more polarization will be there. More polarization, more covalent character. That I want to say. And also many transition metal ions such as titanium 3+, vanadium 3+, chromium 2+, manganese 2+, copper plus, and cerium 3+, and europium 2+, a noble gas configuration is the most effective shielding than the nuclear charge. So the ions without, so these are having without the noble gas configuration, you can say pseudo noble gas configuration will have charge at their surfaces and thus highly polarizing. I want to say without, mean to say what is without? This is without. Got it? Amit, Uttam Kumar, clear? Bhavadharani, good to see. That's nice. Now one more thing, melting and boiling points of ionic compounds. This is very, very important. So one is linked to another one is linked to another one, right? So Amit, you are asking about what is lithium chloride, why it is behaving like that, and everything you will understand here, right? Melting point of an ionic compound depends upon the lattice energy as well as polarization. There are two factors. Okay, ionic compounds has high melting point and boiling point. So that is a fundamental rule. Any factor by virtue of Poisson rule introduces polarization, it is going to be less ionic and less melting point and less boiling point. One more important point. So more the charge, first we have to take the various cases here. And an outstanding thing, but we can have the theoretical prediction of melting point orders only when polarization is one extreme situation. Polarization is one extreme situation, mind it. Okay, that is either polarization is negligible or polarization is dominating. We don't know when to ignore, when to dominate. Now we have to understand this stanza. Amit, all your doubts are going to be cleared now, right? So polarization plays a crucial role. So polarization backbone के फाजान role, yeah. Sometimes it can be ignored, sometimes it has to be dominating parameter. So you need to understand, you need to agree for that, right? Clear? That's what initially you are firing with a couple of questions. I asked you to stay back so that you will understand. Uttam Kumar and Bhavadharani, stay. Where are you? Yes, I am ready. Now let us take when to ignore, when to dominate. Clear? So when the polarization is negligible, अरे अभी तो बोला रहे थे negligible कौन सा condition में होगा? So oxide or fluoride ions are very difficult to polarize the size and high electronegativity, and only few cations like lithium plus beryllium 2 plus aluminum 3 plus can polarize them up to some extent. Under these circumstances, melting point order of the compounds is decided by lattice energy. Okay, just hold on a minute. Just hold on a minute. Now you can see, so when oxide and fluoride ions are very difficult to polarize due to their small size and high electronegativity, and only few cations like you see, yes, very few cations like lithium, beryllium and aluminum, lithium, beryllium and aluminum, right? And they can polarize them to some extent. So these small cations, small anions can be polarized. Under these circumstances, the melting point order of the compound is decided by lattice energy. So whenever oxides and fluorides are coming, ignore polarizing power and you take the lattice energy. Got it? Simple. Rehan Rajpura. So that lattice energy का जो formula है Coulomb's law का हिसाब से, so it is going to be F K Q1 Q2 by R. R is the internuclear distance and Q1 Q2 are the charge of anion and cation. K is the constant. And I just want to say lattice energy is directly proportional to Q1 and Q2, and lattice energy is inversely proportional to the radius. So in this case, I just want to take one example. So when the internuclear distance factor is kept the same and the charge factor Q2, Q1 are varied. Say an example, sodium fluoride, magnesium oxide and silicon nitride, okay, scandium nitride and titanium carbide. You can see Q1, Q2 values 1, Q1, Q2 values 4 and the Q1, Q2 values are 9, Q1, Q2 values are 16. You see the magnitude, and you can see lattice energy is directly proportional to Q1 dot Q2. You know? So lattice energy in the order sodium fluoride, magnesium oxide, silicon, scandium nitride and titanium carbide is in the order. So that melting point order also follows the same way. So melting point order is directly proportional to lattice energy, in which cases whenever fluorides and carbides are there, fluorides and oxides. So hardness order is going to be in the same way. Are you getting or not? Tamil, hi. You got it? You got it? So this is the condition. This is the condition. When the internuclear distance factor is kept same, and so internuclear factors kept same because nearly the sizes are going to be, and with increase in the value of R, lattice energy and melting point decreases because lattice energy is inversely proportional to internuclear distance, right? Okay, can you able to hear me? Children, can you able to hear me? Now you can see an example for the series beryllium oxide, magnesium oxide, calcium oxide, strontium oxide, barium oxide. So here what is kept same? Plus 2 minus 2, plus 2 minus 2, plus 2 minus 2, plus 2 minus 2, plus 2 minus 2. है ना? So here the charges kept same when the charge factor is fixed. It is fixed na? Fixed na? Now you have to check distance factor. You have to check the distance factor. Clear? So that magnesium oxide is greater than calcium oxide is greater than barium oxide is greater than strontium and then barium. And the melting point order and the lattice energy, here you can see the same. It follows the order. If that is the case, lattice energy and melting point both are going to be decreased. Both are going to be decreased. This is the condition. This is the condition. Okay? And don't take as a thumb rule, this always on reverse. It is in the same way. Got it, children? And when you are writing for NEET examination kind of things, you need to know about this. In the NEET examination, it's very, very, very important. ठीक है? मेल्टिंग पॉइंट में अरेंजमेंट कैसा करता है सर? So melting point only I am discussing here. Just follow. ये पुराना कंडीशन, वही कंडीशन में वो सीक्वेंस फॉलो करना पड़ता है. ओके, एंड इट इज ऑल अबाउट मेल्टिंग पॉइंट, राइट? एंड ये कंडीशन क्या है? यही है कंडीशन आपका. टेक द नोट्स डियर चिल्ड्रन, टेक द नोट्स. रेहान राजपुरा, इज दैट फाइन? So when internuclear distance का मतलब क्या? So इसका distance, a distance, this is what you call it as internuclear distance. Same लग रहा है, देखो same लग रहा है, ओके, लेकिन charges अलग है. Yes, so that what happened? Melting point and lattice energy. So lattice energy is going to be increased with charge and melting point also increases with charge. Now if this is the reverse way, what to do that? That's good. What to do that? You can say. So here lattice energy and melting point decreases along with the lattice energy. In that case charges same होना है and sizes बदलना है. Understand? You have to check the size. Sometimes I told you polarization should be ignored some cases. Sometimes polarization is going to be the dominant factor. Clear? Okay. One more और एक example देना है. Amit, don't get confused. Tamil. Rahan Rajpura. Amit, come back. Okay, so let's talk. और एक कंडीशन फॉर दिस सीरीज बेरिलियम फ्लोराइड. अगर फ्लोराइड आ रहा है ना, मैक्सिमम केसेस फ्लोराइड्स आर परफेक्टली आयोनिक. सो where the series beryllium fluoride, magnesium fluoride, calcium fluoride, strontium fluoride, barium fluoride. So in this case melting point order, the lattice energy is going to be decreased in this way. So calcium fluoride is greater than magnesium fluoride is greater than strontium fluoride, barium fluoride, beryllium fluoride. Okay, in this case beryllium fluoride lattice energy is in the reverse order. You can see it is going to be in the reverse order. Okay, so lattice energy calcium fluoride is greater than magnesium fluoride is greater than strontium and beryllium fluoride का कम से कम आना है. So it is going to be the less lattice energy, but melting point का order. So lattice energy beryllium fluoride is more. Okay, so more here, more, this is more lattice energy. So lattice energy and melting point increases, lattice energy decreases. It is in the different way. Now it is apparent that melting point is inversely proportional to polarization. Lattice energy is directly proportional to polarization. P stands for polarization. Here neither charge or the distance both overcomes. Here polarization is going to be dominant. Whenever charge and internuclear distance are dominating, you can ignore polarization, but both are not involving. Polarization is going to be the dominant in this example. So we shall investigate the details about this particular example that is given. It's very important. Whenever comes fluorides, you have to check in the reverse way. So I mean to say, lattice energy decreased, increased, melting point is going to be decreased. Whenever polarization whenever polarization is going to be dominated, right? Now, आगे बढ़ना. So for alkali metal halides, Amit, your doubt. This slide is only for you and all the my students. So for alkali metal halides, here the extent of polarization is less due to lower charge on the cation, because alkali metals are going to be big anions among the entire periodic table, so that the M plus compared to M2 plus in the case discussed in the previous one, So here M2 plus, here charge does matter, but alkali metals the charge doesn't matter, because huge size, okay, huge size. Now I want to say lattice energy order, lithium halide is greater than sodium halide, potassium halide, rubidium halide, cesium halide, where halogen, fluorine, chlorine, bromine, iodine, okay. But the melting point order is going to be sodium, potassium, rubidium, cesium, but lithium, your favorite, Amit, your favorite, why here it is less? My question. Got it? You investigate, you learn from the example, study the example, then you will understand. Don't by heart it. Don't, never and ever by heart it. Conditions पता करने का कोशिश करो. Because of polarization is dominating here. So potassium iodide, sodium iodide, rubidium iodide, cesium iodide and lithium iodide. Sodium fluoride, potassium fluoride, lithium fluoride, rubidium fluoride, cesium fluoride, experimentally determined. And these are the orders that I am giving you. You please take a pen and paper, you write it. So NEET examination में ये आना है. Which of the following is least melting point? Gone. So regarding melting point and boiling point, I think those students have shown 720 out of 720. Even those students also, those students work, but many students in lakhs of students never work on this, right? Now the compounds lithium halides, my favorite point. The compounds lithium halides are not in their original position due to the polarization in lithium halide, and in the case of iodide, sodium is also cause polarization to some extent, and the effect of this is observed in the melting point order only. Okay, this is very important. Everybody take a snapshot of here. Everybody. Take in 3, 2, 1. Click. And covalent character of NaX less than magnesium halide less than aluminum halide. Okay, so you want to note it once, Amit. So I referred minimum 15 books to get out of all these things. Amit, you want to take it up? You want to note it down? You want to note it down? Right. Completed? Once you completed, you just let me know so that we can close this. And tomorrow session we will be discussing all boiling point, melting point and solubilities and conditions. Right? And questions also. Right. That's good. Amit, completed? You said no one can be a perfect reader. Now you can read it, na? Okay. So, fine. So, covalent character order is sodium halide less than magnesium dihalide, aluminum trihalide. Why? Because it is a +1 and a +2 and a +3. So, covalent is directly proportional to charge. Clear? Right. So, melting point order in the reverse way. Why? Because you said not only the charge but also many, where X is equal to halogens, okay, not fluorine, chlorine, bromine, iodine. Whenever fluorine comes na, order ulta fulta hota hai. Now you can say when the charge on the cation increases, the radius decreases, and also here when the polarization P increases and the melting point decreases, again the polarization will vary with the following factors. That is the first point. Okay. When the charge on the cation increases and the radius decreases, of course we know that. And also when the charge on the cation remains the same but the size of the cation increases, the polarization decreases and melting point increases. Based on melting point, you can just pick your hair like this. You can say with a beautiful example for the series beryllium halide, magnesium halide, calcium halide, strontium halide and barium halide. Covalent character order: beryllium halide greater than magnesium halide is greater than calcium halide is greater than strontium halide is greater than barium halide. And of course, melting point order: barium halide should be less than magnesium, then calcium, then strontium and barium halide. So it is going to be like this. So covalent character and melting point order reverse are. So covalent character more and melting point less. That is the fundamental thing. More melting point, less covalent. You can say that. Okay. And also for the series of lithium to alkali metal halides, covalent character is going to be lithium halide is greater than sodium halide is greater than potassium, rubidium and cesium. And lattice energy, I'll come. Tomorrow we'll discuss because time is going on. Na? Tomorrow will you come? Yes, I know that. And you can see, but the melting point order is not decided accordingly. So this is again contradicting. Since the extent of polarization is low, alkali metal polarization is low. We discussed a few questions before you come, and again tomorrow I am going to get some melting point and boiling point questions. Sare ka sara inorganic chemistry se. Is that fine? And it is polarization is low, not enough due to low charge on the cation, charge density on the cation. Now, if you want to go to crack a question in one way, another way is contradicting. In a general, I just want to say the polarization can be dominating, can be ignored, right? Mind it. So, when to ignore? Whenever oxides and fluorides are there, you just focus on the lattice energies. You don't talk about the polarization. But whenever this fluoride and oxide is not there, other salts are there, you talk about the polarization. That is a simple technique. So you decide whether you have to take polarization should be considered or not. That is a simple trick I can give you. Anyways, Today we had a great swell of the class with all inorganic things, and tomorrow also we will be continuing with the same slides, and I'll start with Fazan rule again, and melting point and boiling point and solubility and basic orders that are सारे के सारे inorganic chemistry का orders देना है. Get ready with a new notebook tomorrow, and we had a great swell today. Organic will be discussing after this. Today and tomorrow total inorganic. Is that fine? More excited to go for the organic, huh? Okay. And I just want to say, please like these sessions and getting a good content from the Infinity Learn, and you all enjoy the class and like it and share it with friends and subscribe to the NEET channel. And also in the session itself, I already mentioned, you just go through my session, right? In my session, you are having a description box. In the description box, you click the boost your score NEET Infinity Learn, enroll now. In that you will be directed to a page where you can see all the key features, and also you can see various courses that are available on the NEET, and you can click it on buy now. Okay, you can click it on buy now, and you will be redirected to a page where you can opt for a course where you can just go through. What is my coupon code? You tell me. Add my coupon code Suresh50, and you can enroll now with a flat 20% discount, and this is my course code, and you just enroll there and you can get flat 20% of the discount whatever the course you take with all key benefits. Okay, don't forget to like and share and subscribe this NEET Step Up 2025 program, and signing off. We'll meet tomorrow with more stuff on the inorganic chemistry. Okay, thank you very much. Bye bye. God bless you all. Rehan, Amit. Okay, bye.